All right, let's take it from the top and solve this system of linear equations, but now using our matrix equation method. So the first step is to write the system consistently, lining up your x's, lining up your y's, each one in normal form in the same way. So that first system, look, in this system, there are x's and y's involved. I've got two unknowns. And I have two linear equations, so I'm going to be able to solve it using our method. That first equation I'm going to rewrite as 8x. Now, there's no y in that equation, so the coefficient on y is 0. So I'm going to write 8x plus 0y, and then I want the constant on the other side of the equation, so I'm going to add 27 to both sides of the equation, and so on the other side I'm going to have positive 27. So there's the first equation written in normal form. 8x plus 0y equals 27 is equivalent. The next equation, I'm going to write 5x plus negative 2y. The coefficient on y is negative 2. So I'm always going to write my system with plus signs. And any negative sign would be on the coefficient. So 5x plus negative 2y, and then I need the constant on the other side, on the right-hand side. So add 33 to both sides to get that balanced form, the normal form. 5x plus negative 2y equals 33 is equivalent. I've now got the system in normal form, and I can see the matrix equation. The coefficient matrix is 8, 0, 5, and negative 2. There's the coefficient matrix. The first column of that coefficient matrix are the x coefficients. The second column of that coefficient matrix is the y column. So 8, 0, 5, negative 2 times the column vector of unknowns in order x, y. So x, y, that's the left-hand side of the system. The right-hand side of the system is the column vector of constants, 27, 33. There's the single matrix equation that's equivalent to our system. And now I'm going to, in my calculator, put this coefficient matrix as matrix A, and this column vector of constants as matrix B. This is matrix X, so my AX equals B is my system, and my solution will be X, the column vector of unknowns, is equal to A inverse times B. That's the method right there, A inverse times B. So let's put A in, matrix, edit, matrix A. I want a 2 by 2 coefficient matrix. The first row is 8, enter, 0, enter. And the next row is 5, negative 2, so 5, enter, negative 2, enter. There's the coefficient matrix. Now go to matrix, edit, and let's edit matrix B. It's a 2 by 1 column vector that we're looking for, so that's already there. And I want 27 in the first row and 33 in the second row. There it is. My answer, my column vector of unknowns is going to be A inverse times B. Matrix, select A off the names menu, inverse times matrix B. Let's appreciate how simple this really is. A inverse times B, there's the answer. A inverse times B is equal to the column vector, 3.375, negative 8.0625. And so that says x is equal to 3.375, y is equal to negative 8.0625. X here is this column vector, so you just read its xy order. This is all laid out in the next slide. My solution here, my final answer, the solution to that system is x is 3.375, y is negative 8.0625. You could also write that as an ordered pair, 3.375, comma, negative 8.0625. That's the point in two-dimensional space that is the solution. That's where the two lines would intersect, had we done it using calc intersect. And these are just the steps we went through on the calculator.